You guys hear me? Oh, there we go. All right. All right. Thank you guys so much for coming. A lot of familiar faces, a lot of new ones. So appreciate you guys. Thanks for being here. My name is Kevin Jones. I'm a DevRel engineer working for Edge and Node. I'm going to be teaching you guys a little bit about kind of the graph, how it works, kind of focused on querying, right? We're going to talk about the actual subgraphs that are available, how to kind of gauge what's a good subgraph, how to get that information, how to query the graph. We're going to talk about specifically like how to use various ways to query the graph. I did a workshop here a couple times already that is more developer focused. If you guys want to learn how to build a subgraph, then I would recommend checking that out. There's also a recording of it that I did for the very first time here. It's like an hour and a half long. It's hand by hand deploying a full stack application using Scaffold D2 and the graph. So you guys can check that out. If you just go to bit.ly/fullstackdapp, you can find it. Or if you just look on the Edge and Node YouTube, you'll be able to find the video for it as well. I want to just talk a little bit about the problems with blockchain data and what the graph aims to solve, just to kind of set the stage. But who here has actually used the graph before? So majority of the room, great. So for the sake of just kind of repetition, I'm still going to go over this just to talk about the problems. The first problem that we see with blockchains is there is a large number of transactions and a large number of protocols that are happening inside of a specific Ethereum block, right? Everyone's kind of like trying to get their transactions on the block, and it's a little bit of a sea of a mess to be able to go through and filter through all of those transactions using just a standard RPC provider, right? We also have this issue where the initial architecture for the graph is, or I should say for a dApp, is to have a user interface where you have your front end like HTML, JavaScript, CSS, stuff like that. And then you deploy your smart contract or your business logic in your application on the blockchain. And that's great for writing information, right? The blockchains are actually incentivized for writes. You pay some gas, you sign a transaction, you propose that, and it gets accepted by the network and propagated. But when it comes to reading data, the JSON RPC is not really optimized for large data sets or really just being able to get like, specific information in one request. Like you have to make multiple requests and loop, and it can be kind of a hassle to do that. So what we see is like issues like this, where like someone just wants to get something simple. In this case, they want to get the NFTs for a specific wallet that's connected. Someone has to end up seeing the wallet that's connected, go through, loop over all of the NFTs, build an actual array, and then display that array inside of the front end. So this is fine if there's only like 1 or 2 NFTs in a wallet, but the minute that there's more than that, it greatly impacts the user experience. Something like, let's say a user has 10 or 20 NFTs, it could easily take 10, 20 seconds to load the page on their application. We also have this issue with provenance where historical information for the blockchain is not really easy to get. You can query information by the block, but it's it's very difficult to get, like, let's say you want to get over the duration of the last 100 blocks who had a specific NFT. You literally would have to do 100 calls to the blockchain to get that information, right? And so what we want to do is something more like this, where we have like a historical, or what we call time travel queries, where you can actually go back in time and get historical information for what's happened on the blockchain. So this is where the graph kind of comes into play. So the graph is this single way to provide APIs for decentralized applications for Ethereum, IPFS, and now Arweave and other blockchains. And we serve about 1 to 2 billion queries per day. So that's for the Web3 space. That's pretty large. Actually, for really any any application space, it's still a pretty good number to say that you serve from. And so what we actually see is now with the graph, you can do something like this, where you still have your user interface, your front end that's written in HTML, CSS, JavaScript, right? You still have your smart contract that is deployed to the blockchain, and you're still proposing transactions, paying gas, and using the the blockchain to act as your smart contract and your state machine. But you instead have the graph sitting in this kind of middle layer or middleware as an indexing protocol. And the graph essentially allows you to index these events or blockchain data specifically that comes from your smart contract into the graph and then provide that in a GraphQL API, right? That's the value proposition for the graph. So in the end, we're able to do something like this instead with the example before where we actually had to like loop through and do all these ETH calls. We can just do with one simple GraphQL query to get the entire data object that we care about in our front end, right? So again, the graph is a decentralized index protocol. I think everyone here probably knows that. But what does that really mean? Well, that means that there is a group of indexers or a collection of indexers in the community that are all indexing data and organizing the subgraph information. This data is not owned by the protocol. It's not owned by any company per se. It's owned by the network, right? So these are all owned by individuals. And in this way of deploying, you get access to redundancy. So you can have your subgraph picked up by all the indexers that you signal that to pick up the actual subgraph. This makes the data fast, cheap, and reliable. And really the idea, like again before, is to provide these global APIs, right, for decentralized applications or decentralized data. And in the end, build truly decentralized apps. And that's one of the things that is very core to the graph that we want to stick to, is trying to find out ways that we can continue to decentralize components and continue to empower people in Web3 to continue to build decentralized applications. So what is a subgraph? Really quickly. So you can imagine there is a sea of transactions that are going on at any given moment, anywhere between 10 to 15 seconds. A new block is created, right, on the Ethereum virtual or on the Ethereum virtual machine. The idea is that these subgraphs are able to be created by developers to organize this data in one easy to view API that is customized for the application. And this is all done with the tooling, graph tooling, the CLI, and the Subgraph Studio, and the tooling that's around there, and being able to basically decentralize your data from these smart contracts. So there is a marketplace that I'm going to show off, and really anyone can query the network. It is open and permissionless. And the idea is to create, again, global APIs that anyone can use for the applications and really improve uptime and speed and redundancy of that data, right? So again, we have this kind of like sea of mess of all these different blockchain transactions going on, and we're able to organize those into specific subgraphs. So you can imagine that every popular protocol or application, decentralized application, has a subgraph configuration that is available, and we're going to dive into those and show what those look like. But this is kind of what we aim to do with the graph. And so anyone can publish a subgraph in the Explorer. You can essentially go in there. We're going to go through and do that here in a second and create an API key. But anyone can create subgraphs. And it's funny because even for some protocols, like developers have created these subgraphs and they don't actually even work for the protocol. And sometimes those subgraphs are actually better than the ones that the actual applications create. So in that sense, it is a developer community of subgraphs. This is just a quote from Eugene Ionesco, a playwright. It is not the answer that enlightens, but it's the question. So I think that's very important when you're thinking about data, is trying to figure out like how you can actually use the data to your advantage to provide a better experience and get more insights into your application. And so the graph really empowers that because you can ingest all the data you care about at the time of ingestion of the type of the transactions, and then you can use GraphQL to really formulate the data the way you want. So we're going to start with setting up an API key and then kind of show off the Explorer a little bit. And we're going to kind of show how the playground works and how you can kind of integrate this with the dApp. So let's just set up an API key. So if you go to the graph.com, when you first go here, it's going to kind of bring you to this page, fancy page. And all the products that we have are under here. The hosted service is going away, but that is kind of like our hosted data service. So there's a lot of subgraphs that are built on there already, but I would not recommend getting to use those because eventually that will go away. Instead, if you are a developer and you're creating subgraphs, you would come here to the studio. If you want to use an existing subgraph for your decentralized application, which is what we're going to focus on today, then you'll go to the Explorer. So the Explorer essentially is like kind of like a marketplace. So it shows you exactly all of the different subgraphs that are available, and you can organize them by whatever you want. So curation signal is kind of like the go-to to figure out like which subgraph is the most popular, and that's because if someone creates a subgraph, they can signal some GRT to the network that essentially is kind of like staked, right? You stake this GRT into this particular subgraph because you want the indexers to be able to pick that up, and you also want to use the tokenomics of the network to kind of get paid for your investment. So you can kind of guarantee for the most part that if something has a high curation signal, it is a reliable subgraph, and it's probably been backed by someone who is putting their best foot forward to do that. So anyone following along can just go to thegraph.com/explore. All you need to do is just basically, and by the way, there's two versions of the Explorer. I should say two networks that we support. There's Ethereum, and then there's also Arbitrum One. So we're moving all of the subgraphs pretty much from the Ethereum mainnet to Arbitrum One slowly, because Arbitrum One has way less gas fees, obviously. It's drastically cheaper to transact on Arbitrum One. And so if you are going to build a subgraph, we recommend doing it on Arbitrum One first instead of using Ethereum. And then there are also some migration tools that help you kind of migrate that stuff over that are kind of like early access, I believe, right now, right, Pranav? Migration tools. But if you have subgraphs that are on Ethereum, you can talk to us and we can help you get access to those tools. Oh, it's live now. Okay, they are live. Okay, so let's connect our wallet. Let's go to MetaMask and we'll connect. So I created an account here, and let's see if I click this. It tells me if I have any GRT in here. And then again, we can choose which network we want to be on. So in this case, we'll go to Arbitrum One, and then we can go to that's for the does the studio have the API key? Oh yeah, there it is. So if we go to the studio, when you first connect, it's going to ask you if you want to sign up for an account. You don't have to. You can skip that. But if you go to the API key section, you can create an API key. So the API key essentially gets you 1,000 free queries on the network. So if you want to query the decentralized network, you need an API key. If you're just a developer and you want to just query like the host, the studio for like a subgraph you've created or you have in development, it's actually stored on the hosted service. And so you don't need an API key to be able to test that. But if you want to actually query like a decentralized subgraph, then you need one. So we can just name this test and then create an API key. And then in order to get these 1,000 free queries, we need to do this. So I'll just put blah at edgenode.com and put your name if you want, organization if you want, and then claim queries. So then you get essentially 1,000 free queries, and then you get this API key. So typically you pay for queries through here later on if you go over the 1,000 queries. And we also have subscriptions that we're going to be adding as well. Subscriptions are not live yet, correct? But that's coming soon too. So if you are using the platform eventually for your DApp, you'll be able to say like, okay, I want to do $150 a month in query fees, and you can subscribe to that so that you don't have to continually pay in GRT. But again, this is a free API key, and that's how you create it. And then we can go to the Explorer, and we can just take a look. So I'll search CryptoPunks first. And if you see, we searched CryptoPunks, and there's a bunch of different subgraphs that have kind of popped up, right? So we can kind of say like, all right, well, what is the first thing that we want to look at? Well, the first thing we could do, let's go to Arbitrum One, actually. There we go. So in this case, there is a CryptoPunks here, which if we click on, has 4.2K ETH. And this one is created by, it's Jerry Colo, which is, he actually works for Edge and Node. And then we also have the Masari one here as well. So generally speaking, Masari, I mentioned it earlier, but some of you guys weren't here. Masari is one of the core developers for the graph. And so they are basically working on creating kind of like industry standard subgraphs. And if you go to subgraphs.xyz, you can actually bring up a list of all of their subgraphs that they're working on. And you can also see the status of those. And so these are kind of like organized into different blocks based on their functionality. So like these are all specifically bridges. These are derivatives, futures, and then we have this large section, which is exchanges. But the interesting thing is if you can find one that has like basically a green check mark, if it has a little gear, it's basically in development. But if it has a green check mark, it's basically complete. And you can kind of expect that if you find one in this particular section, that it will have the very same naming convention and the same standard. So if you're building a DeFi dashboard and you want to be able to get access to all the different swap data, then you want to use the Masari one because you'll be able to standardize on the subgraph query language, because the subgraphs are customizable from the developer's perspective. And so you will find there's variations in the naming conventions and how you have to query. But if you know specifically that it is a Masari one, then you can kind of guarantee that you're going to have a very similar, well, exactly similar, as long as it's in the same category. Okay. So that's very useful to know. So always check subgraphs.masari.io, or you can just go to subgraphs.xyz and it will redirect you. So we can look at these examples. So the first thing I always look is, okay, is it a Masari subgraph? If it is, we can kind of guarantee it's going to be an industry standard. It's created by Masari. It's one of the core devs. So we can click on that. And then the next thing I always check and see is there documentation for it. So if you come here, usually it has the website of who built the subgraph, and then it has the actual GitHub repo. So we could click on this, and it will take us to the GitHub repo, and then we can kind of take a look at the documentation to see, like how the subgraph was built. And so in this case, I think there's a subgraphs folder, and here we can see how we have all of the subgraphs kind of organized in here. So I think there should be a CryptoPunks one. Here it is. And then we have like the actual source file for it as well. So we can actually see like, how it was designed. We can see what the schema looks like, which I'm going to get to in a little bit. I'm not going to get too much into that right now, but you get the idea. There's some decent documentation for this one. But you might find that, hey, if you come back to the Explorer, maybe you actually want to use one that's not a Masari one. So let's look at this CryptoPunks here. So this one is the one that was created by Jerry, who actually works for Edge and Node. And so let's check out that repo. It's also got a pretty high curation. It's 4.2K. And if we come in here, we can get a little bit more details. And we might find that by going through and looking at these details, that this one might be more suited for your needs, right? It might have certain functionality that is just a little bit better. Maybe there's some kind of logic that's built into the subgraph that calculates something that you want to get access to that maybe the Masari one doesn't, or vice versa. So before finding which one you want to query, just kind of do your due diligence of looking at the READMEs, and then if you need to, you can actually dive into the source code and see like what exactly is happening in the subgraph. Okay, which I'm going to show what that looks like in a little bit here. Before I go any further, does anyone have any questions so far? No, so there is a pricing kind of. I don't know if you want to say anything about that. Thank you. And there's also in the docs, there's kind of some examples of what like queries would cost, and what like the pricing would be compared to like hosted data that you might have on like Amazon or something like that. You can find it in the docs as well. Yeah, I think isn't there a page? What do you know what it's called? It's like sorry. Oh. Billing. Here we go. So let's see what we got here. Yeah. Yeah. I'll see if I can pull up the page later. There is a page that kind of compares to like, and it gives you some estimates on the docs, but I just don't know exactly where it is. But we'll get back to that. Thank you. So we can look right here, and we can also see, well, the next thing you want to check is that is it properly indexing? So in this case, there's 11 indexers that have picked this subgraph up, and they're all listed here under indexers. So you can kind of see like, some percentage and some metrics about that. We can also see if there's any curators. So in this case, we have one curator. And then we also have access to the playground. So we can actually come in here and start querying the data and kind of preview what that's going to look like. So you can use this as kind of like a testing ground to like build your query of what you want to care about before you actually start using your API key. If you're not familiar with GraphQL, there's this GraphQL Explorer right here on the right. And because we're using GraphQL and we have what's called the schema, we actually get access to all of the data types and the entities that are inside the subgraph, okay? So you can see there's a lot in this subgraph. There's a large number. And so, if you want to find something specifically, one other thing to note is if we look at the source code for the subgraph, which we'll pull up the CryptoPunks again real quick, and we'll go to the schema. Now, the schema, again, it is kind of like the data object and how you want to organize the data for the subgraph. So you can think of the schema as almost like a table, right? So inside of the schema, you have a certain data types that you want to ingest, and then you have their name, and then what kind of data type it is. And another thing I always look for, and I would recommend, is to see if there's comments. So you can see right here that Jerry has added some comments that tells you, okay, this is the punk index. This is the punk owner. This is the events that are derived from this punk. This is the ID of the current ask for the punk, who's basically trying to bid on it, the current bid. So there's really detailed information. And if we come back to here, we can actually come into the playground, and we probably can come to the Explorer and kind of hover our mouse over specific things and get information from it. So if we hover our mouse here, let's see. You can't see it very well, but you can see that it gives us kind of these like hints, right, at the data. So here we can see this is all punks owned by an account. So then I don't have to go into the documentation because someone has actually commented it in there, and I can automatically say, okay, I want to get that. And then I can kind of explore the data a little bit more. So you can build your query just by using this tool here, and then get your results right here. So again, good documentation, access to the actual GitHub repo where the subgraph is. Are there comments in there? How many indexers have picked it up? The more indexers you have, the more high availability you have of the subgraph, right, as well. Okay, so let's keep going. So again, if you're looking for a subgraph, these are kind of like just guides for you. You should first probably see if there's a Masari subgraph. Masari was basically tasked with building these industry standard subgraphs. So go to subgraphs.xyz, find one that actually has a green check mark, and then use that as kind of like your go-to to basically evaluate that one. Next thing, look at the curation level. I already talked about that. The higher the curation, kind of the more signal it has, the more likely it is to be a industry standard subgraph. Check to see if it has documentation, and then lastly, see if it has comments, right? We want to be able to understand what the data is without having to really go into the source code for the actual subgraph. So we did that already. And then there's lots of functionality inside of the playground. Like you can filter. There's logical operators. So if you want to find like if something happened or if something exists, then display this, or different operators are in there. You can also save the queries, right? So if you have like a query that you're kind of working with, you can save it. And if you want to know more about these features, you can go to the graph.com/docs and kind of go from there. So let's look at CryptoPunks. This is just what I always like to do is if we go to the CryptoPunks website and go to Larva Labs and we come over here. So this is the actual CryptoPunks website. And we come down here to the bottom. We can say like, okay, let's say we want to figure out what the largest sale is of a CryptoPunk ever. So according to their website, the number one sale is number 5822, sold for 8,000 ETH, which at the time was $23 million. Still amazes me. But it's pretty awesome. That's cool. But is this information accurate? How would you check this if you were trying to validate this? Probably look on Etherscan, but it would be very difficult to like sift through all the transactions and history and all the blocks. You could go through and run some kind of like loop on the RPC provider, or you could use the graph. So let's use the graph to figure out if this information is accurate. So we'll go to CryptoPunks. We will get rid of all of the existing ones. Okay, so we should have an empty query. So what we actually want to do is look at transfers. The first 10, order by amount, order direction. I think descending is what we want to get. We want to get the ID. Where it was transferred from. Yeah, sure. We'll get the transfer from ID. Let's see, what else do we want? I think that's it. Total spent. I think that's right. Let's try it. I think that's actually not the right one. We don't want this ID. We want the bid. I think we actually want to do descending, let's say, or ascending. No, it's not that one. Oh, maybe it's amount. There we go. Okay, it's not the right query. Okay, so transfers, sales, sorry, that's what we want to look at, sales. So first 10, and we want to go the ID, NFT, and token ID, punk, current bid, current ask. It's a little more difficult than I thought to come through and look at this. Oh, here, amount. There we go. Okay. So, and then we need to do order by price, or amount, sorry, and then order description. Let's see ascending if that's right. Yeah, we need to do descending. Okay. So we were able to create this query. But what was our results? So can you guys see this okay? Zoom in. So the first one is actually in way. So let's do way to ETH. So this one is actually 124,000 ETH. So that's wrong. The website's wrong. But here's the one that's listed on the website. So actually, Punk ID 5822 is the one they have listed as the highest transaction, but it's actually 9998. It was sold for 124,000 ETH. If we were to actually go into Etherscan and look this transaction up, we would see that it was actually a flash loan. Someone bought, and then I think basically borrowed, resold, and then basically transferred. They basically are like censoring this on the CryptoPunks website. But we know that the actual data that's actually ingested by the graph is accurate, right? So this is just an example of, centralized something is providing some data, and you don't necessarily know if it's correct or not. And so you always want to go to the source of truth and see that. And I'm sure there's like some information you can like read more about that. But like I said, they're basically censoring that transaction on the CryptoPunks website. Okay, so again, so we were able to kind of go in here and like formulate our query and get the data we cared about inside of this query. So then we could grab this and then put it into our application. In this case, we would basically say like, well, this is the first 12. So we could actually say like, all right, the amount and change this to first 12. And then we're getting basically the same data set, but it's more accurate data, right? It's true accurate data. Okay, so if you're building a application, there's lots of different ways that you can display the data, right? This particular repo was created by Marcus, who is a DevRel engineer, also working for Edge and Node. And it has examples on how to just do like vanilla JavaScript display of the data. Python, so if you want to use Python to display your results, if you want to use Apollo, or if you want to use Graph Client. Who here has heard of Graph Client? No? Graph Client? So Graph Client is created by the Guild, and it is essentially a framework that you can use inside of your application to do more advanced things, more advanced GraphQL queries. So you can do things like, let's say you have 10 different subgraphs that you want to query. You can configure Graph Client to go out, get all the subgraphs, and display it in one result or one object. So that's very useful if you're like doing something with like DeFi and you want to query the Masari subgraphs. You can kind of combine that data into one response, or well, it'll be multiple requests, but one response. You can also use that with Apollo. It does auto pagination, and there's a video that walks you through how to do the Graph Client setup inside of the repo here. And there's also examples with Playgrounds. With Playgrounds is like another kind of like way that you can do kind of like data science on the stuff as well. And then there's also DApp Locker, which is like no-code dashboards. So again, Playgrounds is actually really cool. If anyone wants to do like Python-based ingesting of subgraph data, I would recommend checking out that. It's really cool. And then if you want like no-code dashboards, DApp Locker is also really good as well. There's a lot of data already in there from like Subgraph and from different like protocols, and you can just easily like pop these into your application as well. Okay, here's the billing subscriptions that is coming. So again, as Pranav mentioned, like maybe you want to set up a subscription plan where you want to kind of set up a certain amount of that money per month that will automatically be applied to your API key. You can set this up soon. Not sure when it's coming, but just keep an eye out. It should be coming soon. And so, yeah, so before we kind of finish off here, I do want to also show an example. So in my workshop, I go through and set this up. This is the Scaffold ETH subgraph package, which is a combination of a hard hat, Next.js, and all of the graph setup running in Docker. And so I've already gone ahead and set this up for you. Again, my workshop goes more into detail about how to do that, but you can kind of assume that we have this kind of like full stack dApp set up right now. And I want to show exactly what it looks like, the entire subgraph configuration. Okay. Who here has actually written a subgraph before? Few of you, like half of you? Okay. So in this case, this particular example, the scaffold ETH example, is a very basic smart contract. It's just a kind of like a hello world smart contract. It has this string that gets emitted called a greeting. And so we only have one event inside of our contract, okay? So this one is keeping track of the address of who actually changed the greeting or announced the greeting. We also have a string that's being passed along that is the new greeting. We have a Boolean that might be set depending on if the user paid some value in the contract. And then we have an integer which keeps track of the count of how many times someone's called this, right? And this is emitted in an event. So if you're familiar with the graph, you know that the graph really is, its sweet spot is tracking event data. So this package automatically comes with a subgraph configuration. So I just want to show it real quick. So it is a mono repo, and it has these 3 different packages. So it has hardhat, Next.js, and then the subgraph configuration inside of the packages folder. And we have this subgraph YAML. So the subgraph YAML is the manifest. It's basically what holds the entire subgraph configuration together. And it just basically tells you what address that you want to ingest the events from, what the network is that you're on, and then also what entities that you care about. We talked about entities earlier, but these are, in this case, we have 2 entities that we're keeping track of. The greeting that gets changed, and then the person that's actually sending and signing the transaction, which is the sender. And then we have a handler that is basically, the handler is what runs every time that the event is fired off to store the data, right, inside the graph. So more importantly, I just want to show the actual schema. So if we go to source and go to schema, we can see what this object looks like. So here we have 2 different entities. We have the greeting, which is, again, it's the message that gets sent basically across the transaction, and then it's whoever's sending it. So the graph has this ability to basically take in these data types. So the things that are coming from the event are the sender, the greeting, and then the premium, and if they paid any value. So I was actually wrong. The the contract here, the event that is getting amended, is actually the value. Sorry. So it's how much ETH they actually sent in the transaction. So did they pay for the greeting? Yes or no, and then how much value was sent. But if we look at the schema again, so go back to schema, and we can see here that we also keep track of some information like from the blockchain as well, like what was the created date, or like the block that it was created at, what was the transaction hash, and then what was the ID. So these parts are actually, these come from the blockchain specifically. This one is generated based on the mapping. And then you can see here that we also do this interesting thing where we do what's called derived from. So that is a way to like link entities or link data types. So inside of the graph, we do that. And we can create relationships between different entities using this derived from field. So every time that there's a new sender, we also create whatever their greetings are, and then we can kind of link those in the background in the database, and then the user is kind of like abstracted from that. So if we go to the mappings, then we can see like how the actual data is being saved on the actual Postgres database inside of the stack, which again, this is not a development workshop, but I just want to go through and walk this through for you and show you. And I want to just deploy the subgraph and show you what the data looks like. So we go yarn. We already ran the entire setup, but we want to do a local create. So this is to create the subgraph, and then yarn local ship. And what this is going to do is actually ship the subgraph to our our Dockerized instance. So we kind of know what the event looks like, right? We see that here. It's a very basic event, but it has all these data types inside of it. And I walked you through the subgraph configuration. And then it's going to ask us what version we can use. We can just do 1. And this is going to give us a GraphQL, GraphIQL query window. So we can pull this up and bring it over here. And this is all running locally. So if you want to like start testing this stuff, again, that workshop that I provided at the beginning, we can actually come in here and do a query. Let's try to grab the, we need to actually make a change. So let's go to scaffold ETH real quick. And let's update the greeting. It loads. There we go. So here we have our smart contract. Okay, why is that doing that? There we go. Okay, that's weird. All right, so we have this ability to change the greeting in scaffold ETH. So we'll just do that. We'll call it House of Web3. This. Not Web2, House of Web2. All right, House of Web3. Oh, we don't have any funds. Let's get some gas real quick and send that. Okay, so we sent this transaction. So now we can hit play. Oh, we need to actually create the thing. So let's do that. Here it is. There we go. So this is really useful. Like if you're trying to do local development, the scaffold ETH package, the Subgraph package has the ability to kind of like toy around locally, but you can see it's a very similar thing. You have this Explorer over here. You can get access to all of the objects here as well inside of here. So you can see like what the greetings were. You can see who the senders were, and you can kind of create that query through here. Okay. But the reason I wanted to show that is one more thing, is the source code. So if we go into our application here, and we go to Next.js, inside of the pages in the scaffold ETH example, we come in here and we look at the app TSX file. We can see here that we actually create the subgraph URI right here, and we use the Apollo client. Okay. And we pass in the subgraph URI query, which is here. This is in this case, we're doing localhost, right, for the contract. And then we actually like do some stuff with the cache. But for the most part, we pass that across in the Apollo provider here. So this is also in that example that Marcus created. I'm just kind of walking you through it here. And then if we go to the components page and go to example UI and go to contract data, here we import the Apollo client as well. So we import GQL. You can kind of ignore all this other stuff. But here we import the Apollo client. And if we scroll down, we can see here where we actually create this GraphQL query as a constant. So in this case, we're trying to get all of the greetings, the first 25, created at order descending and display the ID, the greeting, the premium, the value. This is all the data we care about in the object. And then here we actually like formulate a greetings request over GraphQL. And then here's where we actually make the greeting request and create that constant. And then we log that in our front end. So that being said, we can go to our this contract example UI. So let's do that. So we go to example UI, go to view, developer tools, and we can hit refresh. And here we get the greetings data. It's right here. So if you're a front-end dev, essentially you can come in here, look at the data object, and look at the greetings. So in this case, we only made one greeting change, and here it is, number 0. And we can see where it says House of Web3, right? That was the one that I made. So so basically the Subgraph package of Scaffold ETH really has everything you need to be able to understand how to formulate a GraphQL query. But you can also, again, use the Marcus Rain's workshop here, which also has these examples as well. So there's one for the vanilla JavaScript, which is just like an HTML snippet. Same thing, where you can paste in the query right here, and it will display it in HTML. Then there's also a one for React Apollo query, which is basically almost identical to this one. Then there is one for the Graph client, which I think this is probably the most valuable way to do it, just because Graph client has so many features and functionality. Graph client is definitely the way to go in your application. And then the last one is if you want to use Flask. So there's an example of using Python, right? So if you want to make the query with Python, this is a Python file where you can pass the query and then display that data in a Flask app as well. So lots of examples, and pretty much everything you need is in here to be able to query. So that being said, I think you guys now have a pretty good understanding of how to pick a good subgraph, what to look for, how to kind of like mess with the playground, make some changes, get the data you want, and then move that into your application using any of those options that you have. And if you want to kind of also explore again, I would look at playgrounds. It's also a really good one. Um, Not an actual playground. Playground analytics, there we go. This will kind of be also an easy way. They're kind of like a layer that sits on top of the graph, but it is very popular for like data science. So if you're doing data science stuff, then I would look at subgrounds or playgrounds. They have their own API, so you can essentially kind of use them as like an in-between as well to the graph. And yeah, cool. What kind of questions do you guys have? Yeah. Yeah, so the Python Flask is like an example of how if you were like building an app with Python, you'd use that. That's just like using Python code to display that stuff using the graph. So you'd be querying the API for the graph. So when you come to like a subgraph here and you go to overview, um, you basically have access to like a deployment ID, and then trying to figure out where you get the API. Oh, here it is, query. So here's the query URL, right, for this particular one. You're going through the graph to do that. So you're using the graph network. You're doing it there. If you do it through subgrounds, then they have their own API infrastructure. So they're still using the data that's on the graph, but they're kind of like an abstraction between. They have their own API. So you could technically probably use the Flask option with their API as well, but I think they have like some other toolkits already built for that and some examples to do that as well. Yep. Mhm. That's a good question. So the question was, are you guys doing anything to speed up indexing? So one of the core devs working on the graph is called Streaming Fast. And there are certain subgraphs that do take a long time to index. They're usually DeFi protocols or like something that has a lot of transactions, or like in the case of DeFi, there's a lot of pairs, and so there's a lot of events for each pair, and there's a lot of entities. So Streaming Fast is working on what's called substreams. So substreams and Firehose are kind of a new way of like thinking about of doing the ETL pipeline, so extraction, transform, load. What Firehose and substreams do is they focus on the extraction and the transform part of that. Firehose essentially is a way to take all of the blocks and put them into flat files so that they're parallelizable. And then all of the substream configurations are written in Rust and uses protobuf data formats to basically read in those flat files and then do this kind of manipulative um, processing of the data. So think of it as if you had like a 12 core machine. You could have 12 processes running at the same time, all trying to go through and parse all the blocks. It technically would be 12 times faster than a machine that would need to take its time and do it in a more linear fashion like subgraphs. So yes, substreams is the solution. So Uniswap is one good example. They were able to like speed it up, I think something crazy like 12 times faster, maybe even more than that, 100 times faster or something. I don't know what the metric is, but it's a lot faster. It's just a little harder to do because it is Rust. So if you have a Rust developer, yeah, you can do this using Firehose and substreams. Check out Streaming Fast. Long-winded answer, but yeah. What other questions do you guys have? Yep. Yep. Mhm. The subscriptions for like queries? Yeah. So as of right now, it's not live, but I think we have certain. I don't know, Pranav, if you know. Oh, WebSockets. No, sorry, I misunderstood your question. Yeah, yeah, no WebSockets yet. So substreams are a stream data tooling. So there's some streaming there you can do using the Substream CLI. So if there's a substream available for the data you want, then that's probably the option to go. There's also Substreams.js, which is a JavaScript tool for that, which might be appealing as well. Yeah. Yeah, so the question was, is there a timeline on the hosted service being sunset? No, not yet. Yeah, that should hopefully be known soon. But yeah, we don't have any like set dates. Just more of like a, you know, a path we're going on. Yeah. Cool. Thank you guys so much. Hang out. We're going to have some drinks, and we're happy to answer any questions or talk more. Okay. Thank you guys.